Today we're going to be learning about pouring, loading, running, and staining acrylamide gels. The acrylamide gels I'm providing you with, the separating section has already been poured, so we're going to be pouring the stacking section, removing combs, properly flushing wells, loading our samples, electrophoresing the samples through the gel. Finally, we're going to be separating the glass plates that comprise the gel chamber and removing our very fragile acrylamide gel into a staining solution, staining and destaining for the detection of proteins inside that gel. The acrylamide gels that I'm going to provide you have been somewhat pre-prepared. They'll have a separating gel poured between two glass plates that I have done ahead of time. You are going to be responsible for pouring the stacking gel at the top of the gel. This will sit on top of the separating gel and serves the purpose of concentrating the proteins in your samples down into a tight band before they can be separated out according to their mass in the separating gel. Having a quick look at your acrylamide gel, it's poured in between two reasonably thin glass plates. There's a thicker glass plate in the back and a shorter, thinner glass plate on the front. The glass plate on the back has spacer bars built into either side, which provides the space into which we pour our acrylamide gel. In this case, they're actually quite thin. They're only 1/2 millimeter. So into this space, I've poured enough acrylamide of a particular percentage to fill approximately the bottom 3/4 to 4/5 of the gel, of the gel space. This top section is what's going to be filled with the the stacking gel that you're going to be pouring. Now, when I provide you with these gels, you'll notice that there's a fair amount of buffer sitting on top of the separating gel. I store the gels under buffer to prevent them from drying out. The buffer is the same as the buffer that's in the actual separating gel, so it doesn't change anything about the pH or ion concentration of this acrylamide section. Now, before we can effectively pour our separating gel on top, it's very important, and this is a mistake that many students make, to remove all that excess buffer, or at least as much as is possible within reason. The first step would be, of course, just turn the gel upside down and let some of the buffer drain out over the sink. The second step, to remove the last little bits of buffer in there, is to use the Wattman filter paper sections which I've supplied to you. Simply slide it in between the glass plates, and if you're careful, you can remove any excess buffer without disturbing the separating gel. It's important to not jam the paper in so far that it's actually going to contact the surface of the separating gel. You want to leave that that surface smooth as possible, and the paper will disrupt that. Now, what a lot of students find is that this test tube rack actually makes a fairly handy rack for holding onto the acrylamide gels for the process of pouring the stacking gels. A small little addition here. Occasionally, there can be some leakage of the stacking gel solution down the sides of the gel. I find sometimes that putting a couple of little bulldog clips on either side, very gently, because of course we're dealing with thin glass plates here, can sometimes prevent that from happening. The other thing I like to do ahead of time is to place our comb ready to go in the gel. Now, I'll bring it a little closer so it's perhaps a bit easier to see. It's not depressed all of the way. There's spaces in here into which I can pipette the stacking gel solution. What I find is if I pre-insert the comb somewhat like this and bring the solution up to the bottom of the comb instead of filling it up and then putting the comb in, I get less bubbles trapped underneath the comb. Bubbles trapped underneath the comb will prevent polymerization and make some of these wells that we're trying to form unusable. Now, the next thing, of course, we're going to need is our stacking gel solution. I've pre-mixed some here. You'll notice it's blue, it's a little bit colored. I've added some Kamasi blue to this to make it a little bit easier to see the position of the wells when you're loading it. Again, much like the iGross gels, it can be kind of difficult to see the wells once everything is submerged under liquid. And I find that having a little bit of blue coloring makes it a little bit easier to find where you're trying to put your samples later on. Now, in this tube, there is the separating gel buffer, there is acrylamide, there is distilled water, and I've actually added the APS ahead of time. The one component that's missing is the TMED. Now, TMED is quite volatile, smells quite bad, and is potentially carcinogenic, so we want to be a little bit careful with that. What I'm going to do now is pipette in a small amount of TMED into this, and then I'm going to mix it in to make sure that it's fully distributed. TMED's quite low density, so it can sometimes sit on top. And as I said, it's volatile. If you're not careful, it can evaporate quite quickly, so you don't want to spend a lot of time before getting it mixed. Now, one thing you don't want to do with the solution is to use a vortex mixer. What that will do is introduce a fair amount of air into the solution. Oxygen prevents the polymerization of acrylamide. So we're just going to mix by doing a couple of up and downs like so. No bubbles are introduced, no air is added into the solution. The other thing you're going to want to do is make sure that you're ready to go with your P1000, tip already on, set to a fairly large volume, maybe half a mil at least, because once we added the TMed, basically the clock has started. Polymerization will start to happen right away. We don't want to waste any time between getting this gel ready for polymerization and having it in between these glass plates. One of the big problems a lot of students have is they'll either wait too long between adding the TMed and to add it into the the gel apparatus here, and things will start to polymerize in the tube. Once that happens, you're kind of out of luck and you have to start all over, which again can be a bit of a time-consuming process. So right now I'm going to add the TMed, give it a couple up and downs, and we'll start to pipette it under the comb. Now I'm going to provide you TMed in small bottles, but I have the larger stocked bottle of TMed right here. Got my very small volume of TMed. I'm going to pipette it under the surface of the acrylamide because, as I said, it's quite volatile. I'm going to give it a couple of up and downs, a couple of rotations to mix it in, and then using my larger volume pipette that I have pre-prepared, I'm going to pipette up a volume, and I'm going to add it into the gel space underneath and around the comb. You'll see it should start filling up, at which point I can simply push the comb all the way in. So we've been letting our gel polymerize for a period of time here. A good trick is to hang on to the last little bit of gel solution you have in the tube. Rather than throw that away immediately, you can monitor it. Once it has fully polymerized, you can see here it's actually solid now rather than a liquid, you can be fairly certain that the gel inside your gel apparatus has fully polymerized as well. At this point, you can remove the bulldog clips and remove the comb. I find sometimes tilting the comb up a little bit makes it a little easier to remove the comb, as air can then enter behind it and you don't have that sort of vacuum situation. When you remove the comb, you'll notice bubbles in all of the wells, and hopefully you've got a nice set of well-formed wells. At this point, you can take the syringe that's been provided to you and flush the wells out. Those bubbles are formed by unpolymerized acrylamide. If left in the wells, that acrylamide will eventually polymerize, and those bubbles will prevent you from loading any samples into the wells. You can flush them as many times as you like, removing excess acrylamide. At this point, you're ready to load your samples. You can leave the wells full of buffer. What you're going to be doing is having your samples, to which you have added your loading buffer, and heated to denature and coat any proteins in SDS. To very slowly load the samples into the very tiny space here. What you will find is that you can't actually insert your pipette tip into the space between the glass plates because it is too thin. But if you put the pipette tip against the back plate, the large black back plate, you can certainly slowly pipette your sample, and it will drop down through the buffer because it is heavier than the buffer and sit in the bottom of the wells. When you finish that, you're ready to get together with another group to use the gel clamps to put into the electrophoresis apparatus and move your proteins through the gel. When that's done, we'll be looking at dismantling this gel apparatus and staining your proteins. Once you finish electrophoresing your samples through your acrylamide gel, you should notice a dye front, and your samples will be distributed in here. You won't be able to see them because, of course, at this point the proteins are colorless. You won't see the dye front in this gel. I'm just using this one as an example. The next step, after you've retrieved your gel from the running apparatus and finished the electrophoresis, is to separate the glass plates, remove your gel, and to place it into the staining solution. Now this can be a little bit tricky. The acrylamide gels are quite fragile and they are very thin, so it is easy to tear them. If you tear your gel, it can be difficult to reassemble it to take an efficient picture. you need a good picture in order to establish the size of the bands on your gel. In order to separate the gels, the glass plates that are enclosing your gel, you're going to use this tool, just called a wedge tool. Insert it into the top of the gel. It only has to go in a couple of millimeters, and simply tilt the wedge to lever the plates apart. What you should notice is that the parts of the gel should stick to one or the other of the glass plates. In this case, they're stuck to the back plate. In fact, the separating gel has stuck to the back plate, and the stacking gel has stuck to the top plate. We don't need the stacking gel, so that's just fine. We're going to set that aside. What we have now is our quite fragile, quite thin acrylamide gel stuck to this plate. We can get our container of dye solution. I find this is usually the easiest case. If you start with the dye solution in the container, drop the gel into it, the gel doesn't actually stick to the bottom of the plastic container. Now, give me one moment here. I find the easiest way to remove the gel is to actually hold it upside down over the staining solution. Using a pipette tip, you can gently prise away one corner of the gel, and if you are very careful, what you hopefully will have is it will start to peel away on its own in one piece, and it can be coaxed a little bit into simply falling off the glass plate into the gel solution. And there we have it. Our gel is now fully immersed in the stain. And give it a little wiggle to make sure that it's flat and that it's actually underneath the solution and there's no bubbles underneath it. At this point, this gel and stain solution can go into the microwave for heating and staining, and simply following the staining and destaining protocol.